Let's discuss question number 35. This is from test 2 fluid mechanics. So you have a sliding plate viscometer which is used to measure. So let me just draw a cross section of the sliding plate viscometer. In the front view, the top view is given in the question. So basically the objective is to measure viscosity. The bottom plate will be fixed. The top plate you will apply a force F is required to keep the top plate moving at a constant speed of 5 meters per second. So when you apply a constant force F, initially there will be some tangent motion, but finally with a proper amount of force the plate will come to a constant velocity which is given as 5 meters per second. The thickness is 1 mm and the cross sectional area, the top cross sectional area is 25 into 50 centimeter. So this is centimeter, so 0.25 into 0.5 meter square. Now basically when you are applying, when you want to move the top plate, you need to apply the F. There will be some shear resistance that is set up due to the viscosity of the fluid, the shear resistance into area. So that will be your total resistance provided by the fluid. Now when your effort is equal to the shear strength produced because of viscosity into area, then the net force on the plate is 0 and the plate will move with constant velocity. So that happens when the steady state is reached. Now shear stress due to viscosity, we have to use Newton's law of viscosity, which says that the shear stress developed depends on basically assuming that the flow that has set up is linear in nature. When the flow that has set up, the gap is small, can be assumed as linear. So the shear stress that is offered by the fluid at this point, this depends on the velocity gradient. So it is defined as viscosity into velocity gradient, and for a linear profile, if the flow is linear, the velocity profile linear, we can write V by H. So this can be written as mu V by H into A. So this is the total effort. We need to find viscosity. So if we can measure F, H, the other terms, we can get the viscosity. So this happens only at the ideal state. Okay, so force that is applied will be equal to the force due to the fluid only when the velocity becomes constant. Only then the velocity will become constant. Force is 25 Newton, H is 1 mm, so I just write 0.01 meter. Velocity is 5 meters per second, area is 0.25 into 0.5. So this value comes out close to 0.04 Newton second per meter square, because force meter cube at the denominator, meter at the top, so it becomes meter square. So this is what is the answer. So the option is B. Thank you.